Hello everyone, I am Shubhito Pramanik and my student ID is 0424062538. Today I will be presenting my project for EEE 6609 Deep Learning course, leveraging Direct Preference Optimization (DPO) for enhanced abstractive summarization in Bangla News Headline Generation. News headline generation is a critical task in the field of natural language processing. It requires creating concise yet informative headline from the full news article. Abstractive summarization is crucial in this situation because it can generate more meaningful summary, which is consistent with the context and beyond simple text extraction. While these concerns have been widely studied for English news headline generation, challenges remain in the case of Bangla. First, limited exploration has been performed for Bangla abstractive summarization. Secondly, generative models such as GPT or LLaMA struggle to generate Bangla text fluently even after fine-tuning. Also, lack of coherency, context alignment, and human likeness highlights the necessity to go beyond fine-tuning. So, what we are suggesting is to apply direct preference optimization to solve the existing issues. In this approach, the model will learn to generate headlines that well suits with the standards that human prefers. The process consists of several steps including data selection and preparation, supervised fine-tuning for the downstream task, formation of preference dataset, DPO training, and finally evaluation of performance. I will describe each one by one. First, the data was collected from Kaggle, named as Bengali Text Summarization Dataset. The link has been given here. It consists of two columns, text and corresponding summary of diverse Bangla news. We will use this data to fine-tune our language model. In supervised fine-tuning, a pre-trained model is further tuned on custom dataset to fit it in the downstream task, in our case, headline generation. Fine-tuning consists of several steps starting from data preprocessing, prompt generation, model setup for training, configure the PEPT LoRa for computational efficiency, and finally run the SFT trainer. In this way, the tuned LLM learns to generate a headline for an input news text. Although fine-tuning fits the LLM for downstream tasks, the generated response after fine-tuned lacked context coherence and human likeness, and thus we need DPO which is trained on the preference dataset. In this step, two new columns were added to form the preference dataset. Rejected column carries the fine-tuned response considering its bad quality, and chosen column was a refined version of the reference summary from the dataset. In DPO training stage, we tune the fine-tuned LLM using DPO, which directly optimizes its policy to increase the likelihood of generation of chosen answer over the rejected one. The process has been shown in the figure. In our setup, we picked LLaMA 3.2 1 billion instruct model as our LLM to train on our news dataset. The dataset was split into two portions. 80% data was used for training and remaining 20% for validation. Total dataset had 1000 entries, so 800 for training and 200 for evaluation. Training setup for SFT and DPO has also been shown here with the values of hyperparameters such as LoRa rank, batch size, learning rate, and DPO beta. Now we will discuss the results we obtained in subsequent slides. DPO training achieved a reward margin of 18.75 over the training iterations with an accuracy of 97%. Trend of reward margin and loss over training step has been shown here, which highlights a remarkable rise in reward margin and loss curves downgrades over the time. This is for both the training data and evaluation data. Next, to compare the fine-tune model and the DPO train model to understand the improvement, here we have shown a visual example. For a given text, the fine-tune model couldn't generate a good answer. It hardly can be interpreted. And for the DPO case, the headline generated headline is a good response which is a well suited summary for the provided text. Next, to check the alignment with the reference answer, both the fine-tuned response and the DPO responses were uh, compared with the uh, reference answer, and we calculated blue score to visualize this. So for each instance of the dataset, blue score was calculated for both the fine-tuned model, fine-tuned response and DPO response, and here the plot here shows that DPO surpasses the fine-tuned responses. So mean blue score for fine-tuned generations is 0.0744, while the mean blue score for DPO response is 0.3107, which is uh, greater than that of the fine-tuned generation. Next, the distribution of blue score for both fine-tuned response and DPO response has been shown here, which also validates the results that we have obtained. DPO greatly surpasses the fine-tune responses. Next, to compare our final model, that is the DPO train model, with any of the pre-trained LLM to validate our result, we compared the response of pre-trained Bangla Llama 3.2 1 billion Bangla Alpaca Orca instruct model with our DPO train model. And this shows that our DPO train model has successfully surpassed the response that of the Bangla Llama 3.21 billion Bangla Alpaca Orca instruct model. So possible future enhancement consists of extending the experiments, both the fine tuning and DPO for Bangla specific LLMs. One thing that we observed in our experiment that our fine tune model was struggling to generate a good response. So if we can fine tune Bangla specific LLMs such as Bangla Llama 3.2 3 billion Bangla Alpaca Orca Instruct, or Bangla LLM Bangla Llama 3 8 billion BNWiki base GGUF, or Mistral Bangla on our setup, that could enhance the fine-tune response. And in that case, we also received a good response, a better response after DPO training. So this was one of the future improvement that can be achieved. And next, we can integrate the model in a real-time news application to generate the headlines, and we can incorporate real-time human feedback to enhance the process. So these are the materials that I have used in these projects, and these are the references papers that includes the documentation. So finally, I would like to thank for your attention over the time.